Hello everyone, we are Team KiloByte and this is our submission for Samved Hackathon 2026. So, our project focuses on solving urban mobility challenges for the Solapur Municipal Corporation. Solapur currently faces major issues with traffic congestion and unorganized parking, especially in high density areas like markets and schools. This leads to longer travel times, fuel wastage, and increased pollution. A key problem is illegal and unmanaged parking by vendors and roadside vehicles, which blocks roads and reduce traffic efficiency. Additionally, there is no real-time monitoring or data-driven system in place. This makes it difficult for authorities to manage traffic dynamically or respond quickly to congestion. Overall, the lack of integrated system results in inefficient traffic control and poor parking management. Our project aims to address these challenges through a smart AI-powered solution.
Alright, coming on to the mapping of objective functions and constraints, our solution is designed to directly map real world traffic challenges to an intelligent system functions. Now, we aim to reduce the congestion by replacing static signal with zone based adaptive controls. To improve efficiency, we introduce an interconnected signal coordination across junctions. Parking issues are addressed through vision based detection and real time availability mapping. Encroachments such as hawkers are treated as traffic variables using the AI detection. All data is processed centrally to enable real time decision making. Additionally, emergency response is improved through automatic green corridor generation. This complete mapping ensures that every problem is solved with a specific and scalable system function. We have also mentioned how this function is correlated to each of the subsystem and how the complete constraints are solved and how they are addressed. These are the six objectives that we have tried and follow, and this will make sure that the complete system would run adaptively.
The six objectives of reducing traffic congestion, improving the traffic flow efficiency, managing the parking efficiently, detect the road encroachments, and enable data driven decision, along with improving the emergency response, all of these systems has been tackled and mapped together to detailed objective functions. Now, this constraints would help us in identifying the real world situation and problems and coming up with the solution that we have provided.
Let me explain the architecture and system flow of our smart traffic and parking management system. Our system is built on layered, scalable architecture that enables real-time monitoring, intelligent decision-making, and automated control. Starting with the edge layer, we deploy CCTV cameras and IoT sensors across roads and parking areas. This device continuously captures live data such as vehicle count, traffic density, and parking availability. Instead of sending raw data directly to the cloud, we use edge computing with YOLO V8 on NVIDIA Jetson devices to process data locally. This reduces latency and ensures faster response time. The processed data is then transmitted using lightweight and reliable protocol like MQTT and Kafka to our processing layer. Here, our central processing and analytics engine performs real-time analysis, detects congestion patterns, identify incidents like encroachment, and predict optimal traffic signal timings. Next is the decision and control layer, where intelligent decisions are converted into actions. Our adaptive signal controllers dynamically adjust traffic in case of emergencies. The system automatically detects emergency vehicles and generates a green corridor, ensuring faster and safer transit. On the presentation layer, all insights are visualized through a central dashboard for authorities, providing live traffic status, alerts, and control options. At the same time, citizens interact through a mobile app to check parking availability, book slot, and get optimized navigation routes. Now, talking about the system flow, the data flows continuously from sensors and cameras to edge devices where it is processed and sent to the analytics engine. The system then makes intelligent decisions, which we send as a control command to traffic signals. Simultaneously, insights are delivered to dashboards, police authorities, and citizen applications. Our system is real time, automated, and data driven, transforming traditional fixed traffic system into a smart, adaptive urban mobility solution.
Hello everyone, today I'm excited to walk you through our smart city traffic and parking management system, a unified AI driven platform designed to modernize urban logistics and empower citizens. Now, as you can see, there are two different subparts of the system. The first one is the admin controller, and the next is the citizens one. Now, once you enter your login credentials in the admin portal, the first thing that you see is the live traffic monitoring module, where you can navigate to different sort of zones and analyze the traffic based on the traffic density. You can also monitor and control the signals. Now, these signal controller can be either auto or manual, where the manual controllers can control it manually, and the auto controller is based on the traffic density optimization. Now, once you click on, all the locations are being geo-mapped, so you can easily map them. The next is the parking management, where you can easily track the number of parkings that are occupied. You can easily issue the violations based on any sort of new issue that has been created or the encroachments that has been made. The next is the illegal parking. Here you can resolve either or ignore the parking that has been already done. Now you get a live data monitoring where you can easily monitor and configure them and issue fines. The next is the encroachment and obstruction monitor, where all sort of hawkers and illegal parking would be monitored, and these issues can be easily tracked and configured. The additional feature of the emergency controller has been added, that is referred to as the green corridor, where any sort of ambulance or fire extinguisher can be easily monitored and can be escaped from the traffic. Next is a complete analytics dashboard, where you can see all the traffic density analysis can be easily monitored through and configured. Now let's come on to the citizens portal. So now once you enter the citizens portal, now, once you enter your login credentials, you enter the booking parking system, where you have different zones. On each zone portal, you can see different zones are there, and all the parkings that are being occupied has been marked as red. So for booking a parking slot, you can easily adjust the date and timing and the number of hours you want your parking slot to be booked for. Now, this will book your parking, and you can easily see your parkings at the My Bookings page, and you can either release your parking and pay the number of amount. There's also a section for pay fines. All the fines that you have would be listed at the My Fines page. Next is the report violation page, where you can easily report a hawker parking or any illegal parking by simply uploading the type of vehicle, their number, and uploading an image of it. Now, this will make sure that we have a report generated at the admin dashboard. Once this report is generated, any sort of illegal parking can be managed. So, this was the complete walkthrough of the system. And at the end, our system bridges the gap between municipal authorities and the public, creating a more efficient, transparent, and a safer urban environment for everyone.
Our system is built around five core objectives aimed at improving urban management using real-time intelligence. First, we built AI-powered traffic optimization, where traffic signals are dynamically controlled using our traffic services and monitored through an admin dashboard. Next, the smart parking and booking system allows citizens to view and reserve parking spaces through an interactive map integrated into the citizen portal. For emergency situations, we designed an emergency green corridor which prioritizes routes using real-time traffic data and emergency traffic module. We also included encroachment and violating reporting, where issues are logged and managed through an SMC reporting module and admin dashboard. Finally, our automated fine issuance system streamlines the process of generating and managing files through a dedicated fine service. All these modules are fully implemented and integrated into a unified system. Uh, Now, while building the system, we faced several key challenges. The first was real-time video processing load. We solved this using YOLO version 8 edge-based AI, which processes detections locally and reduces server load. The second challenge was data synchronization, especially for parking availability. We addressed this using Socket.ai, enabling real-time updates across all the users. We also ensured data integrity by using MongoDB for secure storage of evidence and reports with direct document handling. Finally, to manage deployment complexity, we use Docker-based containerization along with the MERM stack architecture, allowing scalable and seamless deployment. These solutions ensure that the system is efficient, reliable, and scalable for real-world smart city use.
Now comes to innovation highlight. The key innovation in our solution is that it converts traditional traffic system into real-time AI powered ecosystem. We provide a central dashboard where authorities can monitor multiple live traffic feeds along with the exact map location. One of our biggest feature is hybrid adaptive signal control. The traffic lights automatically adjust based on vehicle density. At the same time, admin can manually override signals during the emergencies or VIP moments. We also introduce citizen source enforcement, where user can report violation like illegal parking using photos, which are intentionally sent to the admin system. Our system includes smart parking grid with 168 slots, including EV charging support, along with real-time availability to reduce unnecessary traffic. Additionally, the green corridor feature ensures ambulances and emergency vehicles get a clear path automatically. What makes our system better is that connect traffic, parking, and citizen into one platform, improving transparency and reducing congestion. Finally, we use AI-based vehicle detection to optimize signals and generate insight like congestion, hotspots, and revenue tracking. Thank you.